All right, Team B, welcome. So, your partner, Team A, what they ended up doing was reading this word problem. They underlined important information. They identified the unknown, the variables, and then they were able to form their constraints. Okay, so what I suggest you do, I'm going to go through it real quick. So, I suggest you pause it, you look at the underlines, you make sure you read it, you understand it carefully, you underline along with me, and then you copy this graph that's shown on here because we're going to be really needing this needing to use this. So we went up by 2's here. So this gave me a value of 9 for this line. This gave me a value of 13 for that line. And these gave me a values of 30. So when you form your graph, make sure you're going up by 2's. This was 9, 13, 30, and 30. So this problem is talking about a carpentry that makes dinner tables and coffee tables. So we ended up identifying that our unknowns were the dinner tables and the coffee tables because my question is asking me how many of each item should be produced. So we've developed constraints. We developed problems that are some limits that are telling me I need to make at least 9 dinner tables. So x is greater than or equal to 9. I need to make at least 13 coffee tables. So y is greater than or equal to 13. And I need to produce at most 30 dinner tables and coffee tables combined. So when I combine the coffee tables and the dinner tables, at most I can have 30. And again, your partner Team A will go through how these were actually developed if you are not fully understanding how the constraints were developed. Our objective, our job, is to go ahead and find the income function, the objective function. And the objective function is some kind of function that's being maximized or that's being optimized because sometimes it might be a minimization problem. So it's a function based on our problem. In this case, it's going to be some kind of income function. We want to try to find the maximum income possible by me selling dinner tables and coffee tables, right? Get a typo here. So if we go back to our problem, we take a look at here, we see that the shop sells dinner tables for $120 and they sell coffee tables for $150. So I know if I sell a table, I'm going to make $120 off of it. If I sell a coffee table, I'm going to sell $150. But remember, our unknowns where we don't know how many of each we have. But we know that our income, my I function, I'm going to rename it I function, my income function is going to come from me selling $120 for each dinner table and from me selling each coffee table for $150. I'm going to take that and I'm going to try to maximize the best amount of dinner tables and best amount of coffee tables that will give me the most income. In order for me to do that, I'm going to have to take a look at my feasible region, which your Team A went through and developed it along with me in the video. So what ended up happening is in our feasible region, what we have here are multiple solutions, as we've discussed in class. Now I can take all those values, plug them into my income function, and figure out, okay, which one is going to give me the highest income. But a little shortcut for you tells me that if I take my vertices of the feasible function, my coordinate points that form this triangle in this case, if I take those coordinate points and I plug them in, that will provide me with the maximum income that would work in this scenario. Okay? Now, how many of you are saying, oh, Mr. It's the highest one? Well, you never know, right? So we're going to have to give it a shot and try all three to see which one really are going to maximize my income function, because that is what my second question is asking me. What is the maximum weekly income? In order for me to know that, I need to know how many of each item I need to produce. All right, so let's go ahead and grab those points. Let's see what they are. My first one is going to be 9, 13. So this intersection point is 9, 13. So my x is 9. My y is 13. My next point is at this intersection point right over here. And that's going to be 9, I need to trace this back to over here. So if I go up by 2's, I'm 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 21. So that's going to be 9, 21. That's my next coordinate point. And my last coordinate point is this one right over here. I'm going to trace this down. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16. Between 16 and 18, I'm looking at 17. And 17, 13. Now, this is an ideal situation where I'm using just my graphs to find my coordinate points. We're going to eventually jump into the algebra piece. We've done this in systems of equations, where we're going to set these equal to each other. Remember that, using substitution or elimination to find out what that point is. But for now, we'll keep it with just the graphing piece. So now I have my coordinate points x and y. I can take each one and plug them into my income function and figure out which one is going to give me my maximum function, which one of these three vertices. So we're going to take our first coordinate points, 120, parentheses 9, plus 150, parentheses 13. Take those two multiply, add them up. That will give me an income value of $3,030. $. Next, we're going to look at 120, but now we're still plugging in 9 for x, but now we have for y, 21. Multiply those two, add them up. That's going to give me an income value of 4,230. And then the last ones, plug those in, 17 and 13. So 120, parentheses 17, plus 150, parentheses 13. Multiply, add them up. That will give me an income value of $3,990. And were we right? Was it this point? Yes, it was. Is it always going to happen? No. So don't try to take a shortcut here, folks. So what ended up happening is I made a maximum income of $4,230 by me creating 9 dinner tables and 21 coffee tables. That's going to be my answer. So make sure you answer it with words. So 9 dinner tables and 21 coffee tables will maximize my income at $4,230. That's a lot of money. All right, on to the next problem.